Then let's go to another example. Let's say that I want to draw minimal DFA to depict um, the strings whose lengths are divisible by 2. Okay, in all these cases sigma will be AB. Okay, so I want to draw a DFA where the length of the strings will be divisible by 2, which means make a mod galama dekin you should get 0. Okay, so what can be the string lengths? What can the string lengths be? Lengths could be either 0, 2, 4, 6, 8. So whatever the string is, I don't care. Yeah, make maybe A the තියෙන්නේ B the තියෙන්නේ, I don't mind. What I just want is for the length of the string to be a multiple of 2. So my language, if I write my language, I should accept epsilon, which is of length 0. AA අර length 2 set එක මැනව මෙතෙන්ට. ඊට පස්සේ කවුද එන්නේ? length 4 කට්ටිය. So AAAA to BBBB. Then I have length 6 people. Likewise, so this is the language which is accepted by the finite automata. Okay. So if I draw the DFA for this, so I start at my initial state, epsilon on handa, I make it a final state, and that is the start. A hari B hari, I don't care who comes. Okay, I'm at the next state. The මේගොල්ලන්ගේ lengths ලියාගෙන ගියොත් මෙතනින් මම length of the string that comes to state A is 0. මෙතනට එන string එකේ length එක 1යි. Then one length strings of length 1 should not be accepted. ඒගොල්ලන්ව මට ඕනේ නෑනේ. Because those people are not being accepted by this language. Because of that, that particular state is not going to be a final state. Okay. Then the next one, either A or B, I have the next state. These are strings of length 2. 2 කට්ටියව මට ඕනේ, therefore I make this state a final state. Okay. Then length 3, I don't want them, so not final. Then I want 4 people, length 4, that is a final state. දිගටම මේක යනවනේ. Yeah, so this is not going to be finite. Okay, so now what do? I try to make it compact and come up with a simple version, a minimal DFA for this. Okay, so now do you understand that here we made some people final states while the others remained normal states? So what was the differentiation between the normals and the finals? Even length strings, the states that captured even lengths, became final states, while the odd people became normal states. හරි, එතකොට ඔය දෙක depict කරන්න අපි states දෙකක් ගත්තොත් for even and odd. Okay, every time an even person comes, that should be final, while every time an odd person comes, it remains the same, a normal state. එතකොට මතින් තා පටන් ගන්න අපි. I can have A or B, I don't care what comes. මේ පැත්තරත් I don't care whoever comes. දැන් බලන්න මොකද්ද මේකේ වෙන්නේ කියලා. When I write the lengths here, 0 length මෙතන. අර හෙට AB වෙලා ගියාම 1, length 1. They are not accepted. ඊට පස්සේ ඔතනට I AB එකක් ආවොත් එනවනේ අනිත් පැත්තට මෙහෙට. That means length 2. They are accepted. Yeah, because this is a final state. Then another, දැන් හිතන්නකෝ මෙහෙම ඔන්න දැන් මෙතන එක කියන්නේ A ඉන්නේ. ඔකට තව එකක් ආවම තමයි මෙතෙන්ට එන්නේ AA. Now when another A comes, it goes to the other side. AAA length 3. This is not accepted. Length 3. Then when another A comes, A or B, whatever, length 4. It comes back here. It is accepted. Do you understand? That is how it goes. Then you get higher, harder, likewise. So all of the evens are accepted while the odds are rejected. Okay. That sorry, that was when the length of the string was divisible by 2. දැන් හිතන්න අපි ඔක modify කළොත් ටිකක් if length of the string බෙදෙන්නේ නැහැයි කියලා දෙකෙන් බිඳුව නෙමෙයි එකයි කියලා I mean this DFA accepts strings which are not divisible by 2. Not divisible by 2 can the remainder will be 1. එහෙම වුණොත් what should happen? It's the same thing. එකම දේ මේ states දෙක මාරුනවා. මොකද එතකොට අපි accept කරනනේ බෙදුවම එකක් ඉතුරු වෙන කට්ටියව. Yeah. So එකක් ඉතුරු කරන්නේ odd set එක. ඒක නිසා we just swap these two states like this. This is the initial state. So then these people will be accepted while these are rejected. Okay, right. So you understood that these two states in this particular question depicted the evens and the odds. In other words, they can be remainders either 0 or 1. So එක පැත්තක states ටිකේ තිබුණේ remainder එක 1 වෙන කට්ටිය අනිත් පැත්තේ states ටිකේ තිබුණේ remainder එක 0 වෙන කට්ටිය. Okay, so by looking at this pattern, we can say that if we are asked a question where we have to draw a DFA to depict the language which accepts strings that are divisible by 3, string lengths that are divisible by 3, then we know that we have to depict 3 answers, 0, 1, 2. Answers තුනක් එනවනේ. එතකොට we need to have 3 states. Okay, this depicts remainder එක 0 වෙන කට්ටියව, මෙයා 1 වෙන කට්ටියව, මෙයා 2 වෙන කට්ටියව. So 0 ආයව තමයි accept කරන්න ඕනේ. ඒක නිසා this becomes a final state and that is the initial state. AB ආවොත් මෙතෙන්ට යනවා. Another AB I go there. If I get another AB I come back here. Do you get it? This is the 0 length, 1, 2. I'm මෙහෙට එනවා ආවම මෙතන 3 4 5 come back here 6 7 8 9 10 11 12. So these are the ones who are divisible by 3 and they are the ones who will be accepted while the rest of the strings will be rejected. Okay, so in general I can say that when you have a question where you have to draw a DFA to depict something like this, W mod n equals to 0, mod 2 hari 3 hari මොකක් hari, if that is so, then your DFA will have n number of states. hari 3යි නම් states 3යි, 2යි නම් states 2යි, 4යි නම් states 4යි. To depict the remainders you need to have n number of states and the final state of these type of DFAs will be the state which accepts the 0th one. එකනේ පළවෙනි එක. හරි. මේක එක වුණොත් W mod n equals 1 වුණොත් ඒත් n number of states ම තමයි. The one that will be the final state is the 1 length state. Got it? I hope you got that. Okay, let's do another example. Let's say we want to create a DFA where your alphabet is AB. Alphabet is AB and may W can strings. So your strings will be spanning over A and B. Okay, and the constraint is that the number of A's in your string should be equal to 2. Number of A's in the string should be equal to 2, which means A'ලා දෙකට වැඩිය ඉන්න බෑ string එකේ. A'ලා දෙකට වැඩිය අඩුවෙන් ඉන්නත් බෑ. There should be 2 A's in any string. එතන මොකක්ද අපේ බේසික්ම string එක වෙන්න ඕනේ? A නේ. A'ලා දෙකයි එච්චරයි. It was you can have BAA, AAB, ABA. I don't care what the this thing is, the order. Okay, I don't mind what the order is. It's just the fact that I need to have two A's in my string. Okay, so it goes on and on and on. Okay, right. Now, when we want to do the DFA, what do? We draw the basic skeleton. So the basic one is drawn for the basic simple string. What is the, which is the first string? So let's draw the automata which will accept the first string. Simple A. I simple A dunnahama I come to another state which is my final state. Okay, now AA is accepted. Capital ABC. Okay, right. ඊට පස්සේ අපි දැන් මෙතන lengths ගමු. A ලා කීයද කියලා, number of A's. මෙතනදී A ලා නැහැ. Here you have one A. Here you have two A's and that is what you accept. ඒක නෙතනට අපි final එක දැම්මේ. Okay. Now this is not a DFA. Why? Because on A, B, C you haven't decided what will happen if you give a B. Yeah, you have only said what will happen if you give an A. So what will you do if if at state A you get simple B? I don't mind the order of my symbols. එතන මෙතනට මට B ලා කීයක් තිබ්බත් අදාළ නැහැ. මොකද මම මට ඕන කෑල්ල cover කරනවා. මෙන්න මේ කෑල්ලෙන් cover වෙනවා ඒලා දෙන්නෙක් ඉන්න බව. කොහේ හරි තැනක. හරි? එතන ඔය මැද්දේ කොහේ හිටියත් B ලා, that's not my problem. Okay? So I can have any number of B's anywhere. මෙතනත් I don't mind whatever the number of B's I have. එක්කෝ B ලා නැති වෙන්න පුළුවන්, එක්කෝ B ලා ඕන ගානක් ඉන්න පුළුවන්. That's okay. Right? And even at the end, at C, I don't mind any number of B's. I don't care. I can have any number of B's. That's fine. This is accepted because there are only two ways. Okay, or else it could be something like this. This is accepted because there are two ways. Okay, now the problem arises. මෙතනින් පස්සෙත් A එකක් ආවොත් මෙන්න මෙතෙන්ට. If there's an A over here, this should be rejected. ඒ කියන්නේ I don't mind if I get B's over here. C ට කොච්චර B ලාවත් I don't mind, but I do mind if I get another A because then my number of A's, count of A's increase to more than 2, which should be rejected. The strings that are rejected are usually sent to my trap state. So I create a trap state. ඒලා ආවොත් තමයි එකට යන්නේ. And එතනින් එහාට කවුරු ආවත් I should reject. Yeah. එතනින් එහාට තව A එකක් ආවොත් I will still be at D. තව එකක් ආවොත් I will still be at D, state D. Yeah, it's rejected. And if I get a B, I will still be at D. Okay. Upon seeing another A, upon seeing an additional A, එතනින් පස්සට කවුරු ආවත් I should reject that string because the number of A's, the count of A's has exceeded my constraint. Okay, so D here works as a trap state. And so if I continue the lengths, here I have length 2 and 3, number of A's is 3, and here or more. Or more. So 3 or more are sent to the trap state where there's no coming back, so they are stuck there forever. They'll never be accepted. Okay, right. Then අපි කලින් කළා වගේ මෙයාගේ variations දෙකක් ගණ්ඩයි මම දැන් යන්නේ. Okay, කලින් we did variations. Similarly, in the second and in the next two examples, what I'm going to do is I'm going to get not I actually, I'm asking you to draw a DFA to depict the language which will accept strings whose number of A's is less than or equal to 2. That means at most 2 දෙකයි තියෙන්න පුළුවන්. හරි? And another DFA which will accept strings of length which is greater than or equal to 2. ඒ කියන්නේ at least අර කලින් කළා වගේම තමයි. So here you need to have only up to 2 ways. Only up to ඒ කියන්නේ there should be at least 2 ways. Sorry, at most. Okay, at most. At most 2 ways means there could be 0 ways, there could be 1 ways, there could be 2 ways. At least කියලා කියන්නේ there has to be at least 2. ඒ කියන්නේ දෙකක්වත් which means 2 or more. 2 හරි එතනින් එහාට හරි. Okay. Now go to the VLE and I put up an activity. Activity day 2 කියලා තියනවද දැක්කද? අන්න එතන I have asked you all to draw a DFA, draw 2 DFAs rather, where strings of length at least 2 and at most 2 are accepted. Okay, I'm going to give you around 8 minutes. ඉක්මනට එක කළා පින්තූරයක් අරගෙන කොලයක ඇඳලා take a picture and upload it. I'm going to give you 8 minutes. 8 minutes and I'm going to give a countdown. Going to make a okay. So what should happen is when you have at most comma, since you have to capture all of them, you have to give final states. And at least comma, what happens is final state එක දෙකේදී දීලා එතන recur කරනවා ඉතුරු කට්ටිය ඔක්කොමව so that everybody else will be captured there. Okay, so at most එක මම මුලින් ඇන්දොත් what should happen is you have A. When you give A, you come to B, then you come to C. Sorry. B, you come to C. At most handa you can have either 0 or 1 or 2, so everybody is a final state. And anybody who's this is A, and you can have any number of B's, and then any of the A's which come after this will exceed my constraint of length 2. Because of that, they have to go to the trap state or more. And then at least there has to be අඩු ගාන දෙකක්. අතර දෙකට අඩුවෙන් આવොත් ගන්නෑ. අතර එයා විතරයි අපි by the way මෙන්න මේ ඉතලෙත් දාන්න. That is the initial state. So here you can have any number of B's, and anybody who comes after that, any of the A's which exceed the length of 2 are also accepted because this is at least adu gane. Because of that, all the A's and B's are over here. Okay, right. I hope that is clear to you. Then let's do another example. Okay, so earlier we did now this set of examples and the early set of examples are a bit how do I say connected. So now we are going to do something like the number of W's, number of A's in the string W is divisible by 2. Okay, so then so I'm not going to like expand it. I hope you remember. So what you do is you make your first state a final state so that you can accept 0 length ones, I mean even length ones in general, and then you take it to Q1. Let's say this is Q0. Okay, and you come back to this state if you have another. Let's recurse it over here. You can have any number of b's. This is not a final state. Okay, so here what happens is everybody who is divisible by 2 will be accepted. Similarly, if we do that to divisible by 3 thing is 0, then what happens is just like we mentioned before, you will have 3 states. The first one is your final state, which will accept 0, 3, 6, so on and so forth. And the other states will represent lengths like 1, 2, this is 3, 4, 5, 6, 7, 8. So it goes on and on like that. Okay, and if we change this to 1, mod 3 is 1, what happens is this becomes a normal state, this becomes the final state. So the pattern applies here as well. Okay, right. Okay, so that example was connected. This one and the previous one, those two are interconnected. Now let's do a DFA which includes strings, which accept strings which include an A. Hari? Koe hari A එකක් තියනවා නම් I accept. Okay, it could be 1A, 2A, I don't care. Kohe hari if there's an A in the string, I will accept it, which is to say this language is something like somehow or the other it has to include an A. A, B, A, so on. Okay, right. So now what do I do? Now remember this, how do I say that? Trick in mind. Whenever you're asked to draw a DFA, draw the skeleton first, which will capture the simple, the very first, the most basic string in the language. Capture thing. You have one state, you go to your next state. Make initial. Basic A will be captured here. Okay. Then you expand. Okay. Now what will happen if I get a B at A, at state A, if I get a B, I can have any number of B's in front. So I can have a B. Okay. Beta. What will happen if I get now for A, then state capital A gattahama, I have drawn the transition for A and I have drawn the transition for simple B. When I take state B, I haven't done anything for that yet. So think, what will happen if I give A or B to state B? Etana meka discuss kalana. Hari, because I don't care, I only want an A in this. Okay, so as long as an A is captured, the string will be accepted. Okay, right. So that is an automata which will accept strings that include an A. Okay, A එකක් කොහේ හරි තිබ්බනම් හරි. දැන් ඊළඟට අපි කරන්න යන්නේ DFA එක language which accepts strings that end with an A. Right? Ending එක A. ඉස්සරහ මොකක් තිබ්බත් වැඩක් නැහැ. Ending should be A somehow. Okay. So A, B, A. End should the ending has to be an A in all the strings. Okay. Right. So again, the skeleton is A, simple A, B. Yeah, this is the initial state. Okay. Then now since A has to be at the end A in handa, I don't care what comes in front. So I can have any number of B's in the I can have any number of B's before A. Okay. ඊට පස්සේ Then ඒගේ වැඩේ හරි. Then state A ගත්තහම I have written for the transition A, I have written the transition B. එතකොට ඒගේ state එකට වැඩ ටික හරි. But B no. B ට අපි දෙකම ලියලා නැහැ. Okay. Right. Now when we come to B, what will happen if at state B I get a simple A? Now state B is the final state. Okay. If I'm at state B, which is the final state, and if I get another A, අවුලක්ද? නෑ. ඇයි අවුලක් වෙන්නේ නැත්තේ? Because දැන් හිතන්න උදාහරණයකට අපිට ආවේ BBA කියලා. හරි? BBA. So initially I'm at A, B ආවහම I'm at A, B ආවහම I'm again at A. Then when I get simple A, I'm at B. Yeah, so the string is accepted. Now think there's another A here. There's another A. What should happen? The string has to be accepted, yeah, because it ends with an A, which means for it to be accepted, I should be in state B, which means A ආවට මට ප්‍රශ්නයක් නෑ පස්සට, so however many A's that I get after the final A, I will just recurse it at B itself to accept that particular string. But the problem arises when I get a B, ඔන්නෝක පස්සට I B එකක් ආවොත්, then this string shouldn't be accepted. What should happen then? Then I have to send this back to A. B එකක් ආවොත් එහෙම I have to say ඔයා I A වලට ගිහිල්ලා එන්න A එකක් ආවොත්. Yeah, I send it back to A saying you stay there until you meet another A. I A එකක් ආවොත් you can come back to me and then I will accept you. Got it? So this is the DFA to accept strings which end with an A. Okay. ඊට පස්සේ let's do another one. By the way, there's a tutorial for y'all. අද කරන්න තියෙන එකේ මුල කෑල්ල. In the අග කෑල්ල there's DFAs. So try those questions out, and I have assigned the deadline for the submission on next Monday. කීයටද මන්ද දැම්මා මේ ඊට කලින් දාන්න. Okay? And ඒ සතිය tutorial session එකේදී the ones who discuss the tutorial will discuss the questions in the tutorial. Okay? Right. You will have sort of tutorials like that for all of my lectures. Okay, so the next example we are going to do is a DFA. Which accepts strings that start with AB. Okay, so it should have, I mean, all the strings, whatever the string is, AB should be in front. So the basic one is AB. එච්චරයි වෙන මුකුත් නැහැ. ඊට පස්සේ ABA, AB B, AB AA. So this is the language which should be accepted by this particular automaton, DFA. Okay, right. So let's draw the skeleton for the polymer one. So that is you have A, initial, you come to state B upon getting simple A at state A. Then upon getting simple B, you come to state C, that is the final state. That should be the final state because AB should be accepted. Okay. ඊට පස්සේ you are going to expand. Now you think, what will happen if you get a B at state A? When you are at state A, what will happen if you get a B? State A වල ඉන්නවා කියලා කියන්නේ you are at the very beginning of the string. Yeah. At the very beginning of the string, you get a B. Is that possible? No, that string should be rejected because I'm starting with AB. So if I get a B at the very beginning, then that string is not accepted by the language. Because of that, එයා වැටෙන්න මොන කොටටද? reject වෙන කොටට. reject
Hello.
Mom mute
Can you hear me?
you. I didn't even see.
Hello, Dushani.
Hello, hello.
Can you hear me? Something happened. And
Yeah, me do you see the screen?
yeah,
And you hear me, yeah? Okay.
yeah. Okay.
Okay. So upon getting B, a simple B at state A, you come to D, which is a trap state, and ethanium passe kawru avat, you just recurse it there itself, and that is a trap. Okay. Why do we do that? Because the beginning cannot be an A. Sorry, beginning cannot be a B. Okay. Right. Then state A gattahama, we have done the transition for all the input symbols. So that is complete. Now we come to state B. At state B, we have defined transition B. Now we have defined transition A. That is a then balanna. At the very beginning, then up you state B වලට ආවහම at the very beginning I have an A. Okay, that is fine. I have an A. And the second one has to be a B. That is what the language rule says. But what if after the first A, I get another A? You can state B what if I get an A? In that case, මෙහෙම ඒවා අපි entertain කරන්නේ නැහැ. I need to have an A B. A ලව අපි ගන්නෑ. Therefore, if A comes there, that also has to go to the trap. Okay. එහෙම අයව අපිට ඕනේ නැහැ. Finally, C. At state C, then state C ට එනකොට මොකද වෙන්නේ? A ගෙන් අපිට A එකක් ආවා, B ගෙන් අපිට B එකක් ආවා. So I have A and B. So now already my language rule is passed. Now this particular string could be accepted. So after that, I don't care what comes. What follows AB, that is not my problem. So I just recurse it at C. Got it? Okay. That is the automata. This is the automata to represent the language which accepts strings that start with AB. Yeah? AB and whatever.